Thank you. Okay, let's do another problem, how to find vertical, horizontal asymptote, and then sketch the graph. And this is number 56. And remember, always keep two versions of the problem. One with the denominator factored, the other one not factored. Do we factor numerators? There's no need. I don't think it'll make it easier. And write a y value because it's easier to have it in front of us. Okay, we go. So first step is to find xy intercept. X-intercept takes place where y equals 0. Y-intercept takes place where x equals to 0. Let's do y-intercept first. When x equals to 0, numerator will be 6. Denominator will be negative 3. So y value equals negative 2. How do we do x-intercept? We let y to be 0. That means this rational expression equals 0. Rational expression can only be 0 when numerator equal to 0. So numerator, which is 3x squared plus 6 equals 0. And you notice, can I have a real valued solution for x? No, not really. There's no real answers for this equation. So I can't find anything here. Therefore, we don't have x-intercept. Okay, only have a y-intercept. Okay, that's fine. So far we only have 1 point. Next, we will do horizontal asymptote. How is that done again? We are looking for y equals a value when x goes to either far left or far right. Okay. Typically, we divide numerator denominator by highest term, which is x squared in this case, which is the highest. So let's lay it out. Divide x squared. Grab your rational function. Numerator denominator divided by x squared. Let's reduce. All right, now we take the limit. We would like to know what the value, y value is going to approach when x goes to either far right or far left. Let's write down the constants that has nothing to do with x value. Okay, all right, now new concept. Ready? 6 divided by a really, really big number. 6 divided by really, really big number will get close to 0. 2 divided by really, really, really large number, close to 0. 3 divided by gigantic number, close to 0, equals 3. There we have it. Y equals to 3 is our horizontal asymptote. Okay. All right, so let's get a quick sketch just to remind ourselves later what that means. So you have the xy axis to have the system. At y equals 1 and 2 and 3, and at y equals 3, you have a horizontal asymptote. What does that mean? That means when your x goes to far right, x goes positive infinity, your graph is going to hang really close to it, but not touching it, not cross it. And I don't know if it's above or below. Okay. So is when x goes to far left, when x goes to negative infinity, and your graph will get really close to 3, but not touching, not crossing. So let's just keep this for later purpose. What now? Now we're going to do vertical asymptote. Vertical asymptote. Where do you reach vertical asymptote? That is when denominator equals to 0. Okay. So one more time. What's domain again? Domain is going to take place where denominator cannot be 0. Domain takes place when your x cannot be -1 nor +3. Okay. So domain is where your x can be anywhere. Let me write this out. Domain is all about x value where it comes from negative infinity to -1, break it up, -1 to 3, break it up. So that's old information. Vertical asymptote talked about, okay, don't let me to be x equals -1, but what if I just get really close, but I'm not touching x equal to -1, +3? What happens to me? So that's, again, you see these two pieces of information are related. Okay, all right, so I got a vertical asymptote. So vertical asymptote is going to be denominator equal to 0, x equals -1, x equals +3. So here, I'm not going to touch these 2 points, which I'm not allowed, and I just want to find out what happens to the function when I get really close. Okay, and again, how do you get really close? You can come from the left side, or you can come from the right side. Preparation. Let's do the easy one. Come to 3 from the right side, $3, 1 penny. Come to 3 from the left-hand side, slightly less than 3, $2.99. Slightly larger than -1, come to -1 from the right side. Instead of owe people $1, you owe them 99 cents. That's good. Come to -1 from the left-hand side. Owe a little bit more than owe people $1. You owe them $1 and a penny. Okay. Right, left, right, left. Last part. If you have a constant divided by a tiny small number 0, and that's going to get close to either positive or negative infinity. Okay. All right, so that's all the preparation we need, and now we can just go in, do the limit. So there will be 4 ends. Get close to -1 from left, right, get close to 3 from right, and the left from right, left. Okay, let's go look for it. So let's do limit close to -1 first. Set up limit as x approaches -1. Okay, now put a difference here. From the left, from the right. Okay, and let's spell out the function at the meantime, checking to it to see which one is your focus. No, not that, because -1 didn't come from it. No, I don't need to be too careful here because -1 didn't come from it. Now the key player, x plus 1, you notice your -1 came from that parentheses, so super duper careful. Okay, so let me talk about what number I'm going to use. For these two ordinary players, I'll just use whole number -1, but I'll use the decimal in there. Okay, all right. Plugging -1. Plugging -1. Okay, now be careful. Left side of -1. Left side of -1, -1.01. Right side of -1. Okay, equals. Okay, numerator positive constant. Parentheses negative constant. Okay. Now the zeros. Be careful, be careful. And that is a negative. That is a positive. Equals. Write your sign before anything. Okay. All right. So just think these two constants will get together and make another constant. Constant divided by. I should write this out for you. Okay. These two constants will combine together into another constant. But the bottom line is, what is a constant divided by a teeny number? What's a constant divided by a tiny number? Right. Very good. Two more. This time we're going to look at the graph as x come to 3 from left and right. Okay. We're going to go to 3. Numerator. As I'm writing, I'm thinking, is this an important factor will determine the 0 from left and right? No. And what about x plus 1? Not that important either, because our 3 didn't come from it. Now comes to the important one. And you notice that's where our 3 came from. Okay, what's the difference again? We will be coming from the left, coming from the right. Right. So I will use 3 as a whole number in these two factors, but in the x minus 3, I will use the decimal. I just use regular 3. All right, go to our preparation sheet. Okay, from the left, and we will use 3.01. From the right, I will use 2.99. Did I get it confused? From the, I got it switched over, damn it. From the left, I meant to use 2.99. Here we go. I just knew there's something not right. From the left, 2.99, right 3.01. Sorry about that. Left and right. So when you write the constants, just write just use signs. Positive constant and positive constant. Now the zeros, pay attention, pay attention. This is negative 0, and that is a positive 0. Okay. All right, put all of this together. You have one negative sign, and you have positive. Constant divided by tiny number, infinity. Constant divided by tiny number, infinity. Okay, so now we can just sketch this graph. Okay, all right, here's all the information about this graph. Let me get a fresh sheet of paper, be a little bit easier. Put it here. Okay, all right, what did we find? We have y-intercept 0, -2. We don't have x-intercept. We have a horizontal line at y equals 3. Y equals 1, 2, 3. Horizontal asymptote. The graph cannot cross, cannot touch, but the graph will get really close to it at the far right or far left. Again, what's his name? Y equals 3. What is it? Horizontal asymptote. Okay. And then we have two vertical asymptotes at x equals -1 or +3. X equals -1, x equals +3. X equals +1, and that's another vertical asymptote. Okay, very good. Then let's look at the behavior centered around vertical asymptote. -1. Okay. All right. So when I come to -1 from the left-hand side, graph goes way up. When I come to -1 from my right-hand side, graph goes way down. Go to -1 from the right-hand side, way down. Two more. Let's look at what happens around 3. Come to 3 from the left, down. Come to 3 from the left, down. Come to 3 from the right. Come to 3 from the right, way up. Okay. And then we're just going to connect the dots. So let's do this part first. Okay. All right, so I'm going to get really close to the vertical asymptote. I'm not touching it. I'm not crossing it. And then you're like, how high do I go? You decide. Can I touch x-axis? No, because we don't have any x-intercept, so don't touch the x-axis. Okay, and what about this? How do I know my end behavior is going to go above or below? You can't go below because you can't touch the horizontal asymptote, so you have to go above. So this is the right end when you are getting close to the horizontal asymptote. Same reason here, you cannot go below the y equals 3 because here's an asymptote. You don't get to touch or cross it, but you get to get really close to it. Okay. All right, ladies, gents, this is about as far as I have for today. Thank you so much for coming. I will see you next class. Thank you, Judy. Okay, thank you so much.